Good morning class, good morning everyone. In this video, I'm going to share to you how to do binary multiplication. The table for binary multiplication is very short, with only 4 entries instead of 100 necessary for decimal multiplications. So we actually, during our elementary grades, we actually memorize multiplication table up to 100. Okay, so those are actually decimal numbers to the base 10. The binary multiplication table is this. So 0 times 0 is equal to 0. 1 times 0 is equal to 0. 0 times 1 is equal to 0. 1 times 1 is equal to 1. The following examples are given to illustrate the procedure for binary multiplication. Okay, let us have this example for number 1. So, okay, following the rules, let us do binary multiplication. 1 times 1 is equal to 1. Next, 1 times 1 is equal to 1. 1 times 1 is equal to 1. So, in binary multiplication, it's also the same as performing in decimal numbers. Okay, so next multiplier is 0. 0 times 1 is 0 here. Next, 0 times 1, 0. Any number multiplied by 0 is equal to 0. 0 times 1 is equal to 0. So this is the second partial product and this is the first partial products. Okay, next the third, this one. 1 times 1 is equal to 1. 1 times 1 is equal to 1. Next, 1 times 1 is equal to 1. Okay, so the next step you're going to do in multiplication of binary is to add the partial products. So since there are 3 multipliers, 3-digit multipliers, so there are actually 3 partial products. So you add these 3. So in binary multiplication, you need to know first how to add decimal numbers or how to add binary numbers. Okay? So this time you're going to add 1 times, plus nothing is equal to 1. 1 plus 0 is equal to 1. By following now the rules for addition, binary addition. Okay, this time, 1 plus 0 plus 1 is equal to, put in mind that is 2. 2 in decimal, in binary, is equal to 0 plus a carryover of 1. Okay, next, 1 plus 0 plus 1 is equal to 2. So, the same, 0, carry over 1. Okay, because 2 actually is, this is off and this is on. That's why 0 and 1 only, the on digit is only 2. So, this time, you continue adding 1 plus 1 is equal again to 0 plus a carryover of 1. Since there is no digit next to the left column, so you bring down the 1. Okay? So, let us check. The equivalent of these 3 on digit here is 4 plus 2 plus 1, it's 7. So, this is correct. This one is 5. So, 7 times 5 is 35. So, you make sure that this one is also 35. So, this first digit is on. So, you count this one. This is 1. You count because it's on. Next, 2. Numbers which are powers of 2. 2 is on. So, you count. Next, this one is off. This is 4. So, do not count this one. 4. Do not count. This is 8. Do not count because it's off on the specific circuitry. The next digit, the next power of 2 is 16. Do not count this one. Next, you count this one because this is on. So, 16 times 2, this is 32. So, 32 plus 2 plus 1 is equal to 35. So this is 35. So that means this is correct. That is 35. Okay, so let us have another example for binary multiplication. Let us proceed to the next slide. Okay, so next, number 2 example. So there are actually 5 digits on the multiplier. So there are actually 5 partial products here. So any number multiplied by 1 is equal to the number. So if this is 1, you just copy this one. Okay, 1 times this one is equal to the number. So you copy, you just simply copy. No need to multiply it one by one. 0, 1, 1. Okay, so the next is also 1. So you multiply, this is 0, 1, 0, 1, 1. So you just simply copy, because again, any number multiplied by 1 is equal to the number. So you copy here on 0, 1, 0, 1, 1. Okay, next, on the third partial product, this one, this is 1, so you copy again the multiplicand, so that's 0. You write in column here 1, 0, 1, 1. Okay, next, the third partial product is 0. So any number multiplied by 0 is equal to 0. So 5 zeros here. Starting here, 0, 1, 2. There are 5 digits. 3, 4, 5. Okay, so this is the fourth partial product. So you know that you are now in the fourth partial product. Next, this one, 1 times the multiplicand is equal to the number. So you just simply copy 0, 1, 0, 1, 1. Now you have already 5 partial products. So you add all the partial products. You add all this one. So you make sure you know how to add binary numbers. Okay, so 0 plus nothing is equal to 0. 1 times 0 is equal to 1. Plus 0 plus 1 plus 0 is equal to 1. Next, 1 plus 0 plus 1 plus 0. So you just simply count actually. So there are 2 1. So this is 0 carry over 1, because put in mind that is 2 in decimal. So 2 in decimal is 0 1 in binary. So that's why you put the 0 here and you bring down the 1. Carry over. Okay, so next, 1 plus 1 plus 1 is 3. So 0 na here. So this is 3. 3 in decimal. Again, review. 3 in decimal is equal to 1 1 in binary. So you bring down the 1. You carry over the other 1 here. Okay, next, there are 4 1. 1 plus 1 plus 1 plus 0 plus 1. So there are actually 4 1. 4 1 actually is that's 4. Put that in mind that is 4. So if that is 4, the equivalent in binary, it's 0 0. Turn on the 1. So that's 0 0 1. So you write here the 0, you bring down the 0 here, this one 0, and you carry over these 2, this 0 1 above. Here. Okay, so that's 4 actually. Put that in mind that is 4. So 0 plus a carry over of 0 1. 0 1 carry over. Okay, 0 1 actually is 2 in decimal. So if that is 2 in decimal, you think that is 2 plus 1 plus nothing. So 2 plus 1 is 3. 3 in binary is 1 1. So here 1 carry over 1. So this time 1 plus 0 plus 1, that's 2. Think that that is 2. 2 in binary is 0 carry over 1. Again, that is 1 plus 1, it's 2. So 0 plus a carry over of 1. Okay, so this time let us check. Let us multiply first this number. Okay, so let us check. 26, this is actually 26, and this is 23. So you multiply 6 times 3 times 6, so that's 18. Carry over 1. Next, 3 times 2 is 6, so this is 7. Okay, next 2 times 6 is 12. Carry over 1. 2 times 2 plus 1, so that's 5. So you add, this is 8, 9, 598. So if this is 598, our answer actually is correct. So let us actually write the value here. This is 0, 1. Our answer is 1, 0. Next is 1, 0, 1, 0, 0, 1. Okay, so in this case we are going to add this table. So 256 times 2, that's 512. So we are going to add numbers, powers of 2, since we have a large number. Okay, so 512 is on, so you count. So let us add 512 plus 64 is on. Another number that is on is 16. Next is 4 and 2. Okay, let us add. If the sum of this is 598, meaning our answer is correct. Okay, so this is 6, 12, 12 plus 6, 18. 18, carry 1, 1 plus 1 is 2, so this is 8, 9. So this is 9 and 5. Okay, so that's 598, the value of our binary here. Okay, so that means our answer is correct. Let us have another example, the fractional part for binary multiplication. So here let us multiply 0 times 0 is equal to 0. Any number multiplied by 0 is equal to 0, so just simply write 4 zeros here. Next, this one, 1 times 0 is equal to 0. 1 times 0 is equal to 0. 1 times 1 is equal to 1. 1 times 1 is equal to 1. Next digit, this one. So 4 zeros. 1, 2, 3, 4. Next, 1 times 0 is equal to 0, the fourth partial products. 1 times 0 is equal to 0 again. Next, 1 times 1 is equal to 1. 1 times 1 is equal to 1. Okay, so in multiplication, you add the 4 partial products. So this is 0, 0 plus 0, 0, 0, and this is 1 1 1 1. Okay, so let us check if this is correct. So since the same in decimal, just simply count the number of decimal places. So this is 2 here, so you count 4. In multiplication, you count 1 2 3 4 here, 4. So the decimal place is here, decimal point. Okay, so this time let us check if this is correct. Okay, so 3 1, actually this 3 1 is 7. Okay, on the 1 is on, 2 is on, and 4 is on, so that's 7. 0.5 actually is this one, point 1. 0.1 actually is that's that 0.1 here, so that's all. 0.1 in binary, so meaning this is subscript 2, that is equal to 0.5 in decimal. Okay, so look at the sample here, the 0.5, this one, the equivalent. So just simply from here, from the decimal point, this 0 actually is, the exponent here is 0, or this one 0, and this is the 0 multiplied by the base 2 is 0. Okay, so this one actually is here, put here, times 2 raised to the power 1. It will increment by 1 from the left most to the right from the decimal point. So from the decimal point to the right, we'll start here -1, -2, -3, and so on. So look at here, -1 is this one, this 0 is for -2. Okay, so this 0.1 actually is on -1 here, so that's the value of that in decimal is 1 times, since that is at the right of the decimal, times 2 raised to the power -1. So if that's -1 here in math, this is actually equal to 1 over 2 raised to the power 1 to remove. So this is actually equal to 1/2. 1/2 actually is 0.5. 1/2 is equal to 0.5 in decimal, because that's 5/10, or you just simply divide, if you want, 1 divided by 2 to make sure that this is 0.5. 2, so add 0 here, so that's 10 divided by 2, so this is 5 times 2, it's 10, 0. Okay, so that's actually 0.5, and the 7 is here, that this 3 1. Okay, so that's all on how to multiply binary numbers. Thanks for watching.